Swayam Prabha. Digital India. Educated India.
Hello everyone. We will now start the analytical approaches of measuring the maturity of fiber. So maturity term basically used for only for cotton. Other than cotton, we normally don't use the maturity. So we will only concentrate on maturity of cotton fibers, because maturity is related with the growth of fiber. So this concept is essentially confined to cotton only, and we rarely use for other fibers. And it's a very important feature for cotton, and the fibers, the main feature in a cotton is that the central part. Suppose if we see a cotton fiber, the central part of the cotton fiber, the lumen, is a most important feature of cotton fiber, which is doesn't exist in other fiber. So this lumen, the area, it indicates the maturity, whether it will be matured or immature. And if you, so while the cotton is in growing, so there will be primary layer, primary cell, primary wall, secondary wall, and the lumen will be there. During the growth, secondary wall, actually the thickness increases and lumen gets reduced. Area of the lumen gets reduced. So it gets thicker and lumen gets narrower during the growth. So outside diameter of the fiber doesn't change while development. That means the perimeter doesn't change during the growth stage. Initially it develops. As the fiber develops, this remains same, but the secondary wall grows and become thicker and thicker. So new cellulose is laid on the secondary wall, and which is basically which is indicating the maturity of. Initially the fibers are circular, and there is a lumen. This is a lumen which is hollow part, and the secondary wall gets thicker and thicker. Okay, and this is the called developing stage. And if the secondary wall formation is not proper due to some different factors, then it will be called as immature fiber. So the secondary wall typically represent major part of the thickness of fiber. So it essentially determines the state of maturity. Now if you see here, in this fiber, you can see that the lumen central part, the area of lumen is larger because secondary wall formation was not there proper. So that's why it has become immature fiber. And where the secondary wall formation is good, its thickness has increased and lumen has compressed. So between these two, the ratio of lumen and the secondary wall represent the thickness of the secondary wall, and the lumen represent the maturity, level of maturity. Suppose here this is the thickness of its H and lumen thickness L. So H by L is a representative of the maturity level. Okay, but there may be situation where the secondary wall formation was completely missing. It is very thin, and this part is central part is the lumen part, and when the fiber gets dried, it collapses and the cross section becomes this, which is called dead fiber. The problem here with the dead fiber is that due to absence of the secondary wall growth, the basically when we dye the fiber, the mainly secondary wall absorbs the dye particle and the color it gets colored. But in absence of the secondary wall, when during dyeing, if the dead fibers are present in the mixture, so that these fibers will, the dead fibers will not absorb dye particle, so it will remain white spots will be there. And also, as this fibers are flat in nature, the fibers, the flexural rigidity will be low for the dead fiber, and this will form naps. It has been observed that naps are predominantly formed by the dead fibers. So, what are the importance of maturity fiber, maturity of cotton? So we need optimum degree of maturity. It should not be too high. Maturity, if it is very high, then fibers will become stiffer. Stiffness will increase. Okay, fibers will become very stiff. Okay, and if the maturity is low, so fiber will be flabby and it will lack resilience. So if it bends, it will not come back to their position. So that's how the naps are formed. But for as far as spinning is concerned, the over mature fiber, although they create problem, the problems are lesser problem than the immature fiber. And immature fiber basically forms the naps, which remains in the yarn and ultimately in the fabric. So these naps are basically generated due to the date fibers, as I have mentioned already. So during dyeing and printing of cotton fabric, this thin walled fibers, they don't absorb dye, and either they are to remain totally undyed or lighter shade than the matured fiber. So it results the streaky dyeing, which gives adverse effect. So you can see here, this is the piece dyed fabric, and we can see the white spots. These white spots are mainly due to the naps, and which are not being dyed, which didn't absorb dye. Now we'll discuss different parameters to express the degree of maturity. First parameter is called degree of thickening, which is expressed by the symbol theta. So here, this is the fiber cross section, and perimeter is the total length of the outer surface. So the degree of thickening is expressed as the ratio of the solid cross-sectional area of fiber A. That means this is the solid cross-sectional area of fiber. This is the fiber. This is the A is the cross-sectional area, and if we see the perimeter, although it's a bean shaped, now let us convert this bean shaped with the same perimeter to a circular cross section. This bean shape, we are converting it to a circular cross section. This cross sectional area is AG, and the ratio A by A0 here is okay. So with the same perimeter, the circle, if we form, the area is AG. So theta range is typically 0.8 to 0.9 for normal cotton. But it's very difficult to measure the perimeter of fiber and also cross section, that perimeter of fiber, cross sectional area of fiber, but we can measure indirectly. We'll discuss, but directly the new system, which is AFIS method, we can measure directly the value theta. So solid cross sectional area by of fiber by a circle bound by its perimeter, same perimeter. Here cross sectional area A of fiber and the same perimeter we are using, cross sectional area of circle is A0. Now P perimeter equal to pi d, where square of perimeter is pi square d square. A0 is area of circle, so d is the diameter of circle. So if you see, A0 is pi d square by 4, so we can replace perimeter here, so it will become p square by 4 pi, and A0 we know, at A we can get, so ratio of A and A0, so here it will become 4 pi A by p square. So this is the theoretical approach of measuring the theta. Now maturity ratio, it is expressed by the mass per unit length, so average mass per unit length of fiber and average mass per unit length of fiber of standard fiber, so this is the maturity ratio, but in practical, in laboratory we don't measure in this fashion maturity ratio. We will discuss, we measure the maturity ratio using one empirical equation, and this we will discuss later. And maturity count is that it's a n minus d. N is the number of normal fiber and this is dead fiber. That we have already discussed, what is normal fiber. And it's a normal fiber. This is not the absolute number. Here it's a percent normal fiber. D is the percent dead fiber. Now let us try to do one numerical. The degree of thickening theta of a cotton fiber is 0.5. The cross sectional area of cotton fiber is 7 multiplied by 10 to the power minus 4 square millimeter. The perimeter has to be calculated. So from the earlier relationship we can calculate. See, this was the relationship. So here theta is given and cross sectional area of cotton fiber this is given. What we have to calculate, that means this is given, what we have to calculate, p value. So using this relationship we can calculate the p value as 0.1326 millimeter. Okay. Next method is caustic soda and microscope method. So there are different methods. This caustic soda and microscope method, double compression method, caustic air method, high volume instrument is the instrument, third, AFIS method, image processing techniques, and near infrared. So earlier what we have discussed, different parameters to express. Now in caustic soda and microscope method we express the maturity ratio we have discussed earlier. So M by the ratio of the linear density of fiber. But here in caustic soda method, although we measure the maturity ratio, but here we don't measure the linear density, we measure based on the number or proportion of dead normal fiber and dead fiber using one empirical equation. We get the maturity ratio. So approach is different here. Now caustic soda method is very simple, very commonly used in measuring the maturity of cotton fiber. Fibers are first dipped into diluted caustic soda solution and gets swollen. So the matured fibers quickly swell the caustic soda solution due to the presence of secondary wall, and it becomes the cylindrical circular cross section, and this is the secondary wall, and immature fiber become flat. Okay, inside is lumen, and from there we can differentiate, we can classify the number of fibers of normal fiber or mature fiber, immature fiber, and also the dead fibers, which are not at all absorbing and getting swelled. So three types of fibers we can call it as half matured fiber and dead fiber. We can classify this. So the more immature fiber ones retain their ribbon-like appearance to some extent. So ribbon-like appearance will be there. So apparent thickness of the secondary wall is determined. So basically, if you see, you can see here, with reference to the lumen, apparent thickness will be determined. So normal fibers are those who have got deconvoluted and rod-like appearances. So, and dead fibers, as we have mentioned. So what we can now classify, and from there we can see here, this is a normal fiber, and after swelling the fiber shape is becoming circular cross-sectional shape, but dead fibers remain in the flat image. Fibers are swollen in 18% caustic soda as per ISO method. Then they are grouped according to the dead fiber as a classification, normal fiber and thin walled fiber. Okay, so you can thin walled, we can say half matured. This is normal fiber and dead fiber. Maturity ratio is then calculated using the standard empirical formula, and this empirical formula is actually developed based on the assumption that typically 67% of fibers are normal fiber, where 7% of fibers are dead fiber and 26% fiber are half mature fiber. From the large sample size, it has been observed that for completely normal fiber, normal standard for any standard fiber, this is the proportion. Now, and here n is the percent normal fiber and this is percent dead fiber. Now, if we, and how this 0.7 came here, now if you use 67 minus 7 by 200 plus 0.7, that means it will become 60, and 0.3 plus 0.7. So we have already discussed that maturity ratio is M is H by HS. So for fiber, if it is for standard fiber, it will become 1. So that's why this empirical formula is changed. One thing as one should remember, this N and D are the proportion of fiber. It's not the number of actual number. Percent of normal fiber and percent of dead fiber. So here we don't consider the half mature fiber. Only two classifications are there, and remaining the immature half mature fibers we don't take into consideration. So any maturity ratio less than 0.8 would be regarded as a poor quality immature fiber, and if we see the relationship, maturity ratio equals n minus d by 200 plus 0.7. Now theoretically, ideally, suppose all the fibers are normal fiber, no dead fibers, no half mature fiber, that means n will be 100 and d will be 0. So in that case 100 by 200 plus 0.7, 1. Okay, and another case, this is a 100% mature fiber, and another case, say all the fibers are dead fibers, no development. In that case maturity ratio will be minus 0.3 plus 0.7. Sorry, 0. Sorry, this is 0.5. This is 0.5 minus 0.5, so it will be 0.2. That means the theoretical range from the all dead fibers where maturity ratio is 2.2 and all the fibers are mature fiber, it will become 1.2. So maximum possible maturity ratio could be 1.2, where all the fibers are mature. So it is 0.2 to 1.2, and the empirical equation relationship which has been observed, it's a theta equal to 0.577 m maturity ratio. So this relationship is developed based on large number of fiber samples from different zones. So if we want to know the degree of thickening, first we have to measure the maturity ratio, then we can get the degree of thickening. So as this range is 0.2 to 1.2 maturity ratio, so this we can get the range for the theoretical range for the degree of thickening also. Now try to see few numericals. The first one is that on examining 180 cotton fibers, 100 fibers were normal fiber, 50 semi-mature fiber and 30 dead fibers. The maturity ratio. So first 180 fibers. So we will not consider the semi-mature fiber, only normal fiber and dead fiber. What we have to do first? We have to get the proportion, percent normal fiber. What is the percent normal fiber? 100 out of 180 100 normal fiber, total 180 fibers were selected. So what will be the percent? This is the percent of normal fiber. So that we will discuss. And so this will be a normal fiber. This will be normal fiber. Normal fiber, it will be 55.55. 55.55%. So it's a 55.55%. And percent dead fiber will be 30 divided by 180 multiplied by 100. It will be 16.66. Okay. And this we can use the formula M equal to N minus D, 55.55 minus 16.66 divided by 200 plus 7 we will get. So you can see here using the equation, this equation is given. So dead fiber percent 55.55 and it is 16.67 getting, and we can calculate the maturity ratio. It's a 0.894. Next is that on examining 150 fibers, similar problem, 75 normal fiber, 45 semi-mature and 30 dead fiber. The maturity ratio can be calculated using the same formula. In a similar way, we can calculate the maturity ratio. So percent normal fiber becomes 50% and percent of dead fiber is 20%, and we can calculate the maturity ratio as 0.85. Another example, on examining 160 cotton fiber, 80 normal, 40 semi-mature and 40 dead fiber. So similar way we can calculate the normal fiber, mature fiber, semi-mature. So percent we can calculate here. So you can get the percent. So 50% is normal fiber, 25% will be the dead fiber, and we can calculate using the same relationship. It's 0.825. So we can see here this fiber is a little bit less mature than the earlier fiber. Earlier was the 0.85. So that means number of the ratio, that the proportion of the mature fiber and immature fiber, mature fiber and dead fiber, which will determine the degree of maturity. Next option of caustic soda method is, there is a basically here we can group the fibers into only two types of fibers, two groups. One is mature fiber, rod-like shape, which has wall width more than 1/4 of the ribbon width. Wall width means wall of, suppose this is the fiber cross section. So if you see cross section, this is the wall. Now when we see under the microscope fiber, this is the wall width. Wall width, this wall width, and the total ribbon width, this is the total ribbon width. If this wall width is more than 1/4 of the total width, which we will call it as mature fiber, and if it is less than that, then it will be immature fiber. So simply it is basically maturity ratio, maturity percent. Here number of mature fiber by total number of fibers. That way we can calculate the maturity percent. Double compression method, which is used, that where we take a certain specific quantity of fiber, say 4 gram of fiber, and then we open it and mix it properly, and then pack in a constant volume, and constant airflow is passed to the sample, and pressure drop is recorded, and then we pack it with a higher compress it with a density twice to that of earlier one. That means it is compressed, and then we pass the air, flow the air, and then pressure drop is recorded. So we will get this in two different points, and we compare it with the this is the process. Here you can see in the compressed condition, in the initial condition here. So then we, with the help of a regression equation, we can get the maturity value. Caustic air method is another method which is as per the ASTM method. So when we treat the fiber or dip the fiber into the caustic soda, fiber gets swelled, similar to the fact that chemical treatment of cotton with the caustic soda, it gets swell, and then we measure the airflow. So utilizing the standard airflow instrument, a test is made on normal cotton and on cotton sample which have been swollen in the caustic soda. So before swelling and after swelling, we measure the airflow rate, and if it is normal cotton, it's a mature cotton, then the diameter swelling will be higher. So that ratio of airflow will indicate the level of maturity. Next is the high volume instrument method, but there is no such module in high volume HVI method, no such volume for measuring the maturity, but fineness is an indicator of the maturity of cotton. So for the same variety, if the fineness is it's a finer, it shows its a fineness is less, that means micronear value is less, that means the fiber will be immature. That is indication for a particular variety of cotton, but there is no direct method of measurement of maturity in HBI. Okay, so micronear value is indication. And AFIS is a method where we can get the theta, that is degree of thickening, because we can get the total shape of fiber. It determines the shape of fiber, where the light, due to light scattering, we can actually identify the every coordinate point, and we can measure the actual perimeter of fiber and also that actual area of fiber. P can be measured and A can also be measured, and using the standard formula we can measure so P can be measured directly and area can also be measured directly. We can get direct value of the degree of thickening in AFIS method. AFIS is the only method where we can directly measure the degree of thickening. So shape. Now from the AFIS data, as I have already mentioned, that we can get the coordinate of each and every point. So what we can get, the circularity is expressed by this relationship. That means the circularity C for a circle, it is 1. If it is circle, it will be 1. Okay, circularity. And if the circularity is less than certain value, we will call it as immature fiber. So immature fiber content in percent. So if the circularity, percent of fiber with circularity less than 0.25, okay, circularity, then we will call it as immature. Maturity ratio is the ratio of number of fibers with a 0.5 or more circularity to a number of fibers 0.25 or less circularity. So that's an indication of maturity ratio here. This maturity ratio is as per the AFIS. Then image processing method, cross-sectional images of mature and immature fibers are obtained, and then degree of thickening, wall thickening is calculated using image analysis technique. So in image analysis technique also we can measure the theta. So if you have a fiber, if these fibers are there, we take image photo, and then by image analysis we can calculate the actual area of fiber. So this is the fiber. So mature fiber image, immature fiber image, that we can calculate. And the last technique is that it's a near infrared method, where it's a very fast method and it can measure based on the absorbance spectrum with the different with respect to the wavelength of cotton fiber sample. So if the wavelength, with the change in wavelength, the absorbance is changing, and this spectra, it depends on the different maturity of fibre. So depending on the secondary wall content, the absorbance changes. So effectively the secondary wall, presence of secondary wall is the indication of maturity. So near infrared is one method of measurement, and we have come to the end of this session. Thank you.